Hello, everyone. Welcome to a Jenkins online meetup. I'm Liam Newman, your host, and today I'll be talking with James Strachan, the lead on the Jenkins X project about Jenkins X, automated CI/CD for Kubernetes. So James, tell us about that.
Shall I just start my slides? Because I'll end up telling you about that in like 2 slides time. Let me set the scene a little bit before I talk about Jenkins X.
Sure.
Because I want to give a little bit of background about the problems that people have, and then I'll introduce Jenkins X. So let me do a quick step back. So a lot has happened in the last 5 years about how we build software, package it, release it, deploy it, manage it, right? If you're trying to be a high-performing team, almost everything has changed in what you should be doing these days. Okay, so there's a huge move from on-premise to public cloud. That's been going for probably about a decade, but it's really exponentially ramping up in the last few years. It's much easier to elastically scale your infrastructure on the cloud rather than guessing what hardware you're going to need next year and then buying office space and machines and doing your own kind of private data centers. So there's this big move to the public cloud. In addition, there's this big move away from virtual machines to containers. And the main reason for that is really just cost. A container is smaller, uses less CPU, disk, memory than a virtual machine. So traditionally, we've often used virtual machines as a way of deploying software into staging and production environments. Increasingly, there's now an economic need to move from virtual machines to containers. So that's a fairly big change. Then in the last kind of 4 years, something called Kubernetes has come along, which is basically the industry standard way of orchestrating containers at scale. Kubernetes came out of Google, and it's basically an implementation of what Google has been using internally for about a decade. Everything at Google runs on a container or in a container. So whenever you use Google Search, Google Maps, anything that Google does, you're using containers. And the big problem with containers is how do you manage them all, right? Once you split all your applications into lots of little containers, how do you keep them all running? How do you do load balancing? How do you scale up and down? How do you make sure they're all running all the time and they can all talk to each other and so forth? And that's really what Kubernetes does and why Kubernetes exists. And this year, 2018, is basically the year that Kubernetes won. Kubernetes has become the standard way of running containers at scale on any cloud, right? Whether it's public cloud, private cloud, whether it's your laptop. In 2018, all the major cloud providers will have something called a managed Kubernetes as a service. And what that basically means is this year you can pick any reasonably popular cloud provider, certainly the big 3 in the Western world and Alibaba in China. So you'll be able to go to Google, Microsoft, or Amazon's website and say, please give me a Kubernetes cluster. And you pick how big the cluster is, how many nodes you wish to use, how big the nodes are, and so forth. And then the public cloud vendor will manage Kubernetes clusters for you. They will keep those nodes running. If a node fails, they will automatically restart them. You'll be able to elastically scale the cluster up and down to your heart's desire, and you'll be basically billed in terms of how much compute nodes you use, how much computing and memory and disk you use. In many ways, Kubernetes on the public cloud is basically free now. Like a completely managed, hosted Kubernetes service is basically free. You just pay for the compute, disk, and network of your actual containers that you run on Kubernetes, right? Which is pretty cool. So this huge change from on-premise to public cloud, from VMs to containers, and the move to Kubernetes adds lots of complexities for developers, right? Not many developers even know what Kubernetes is yet, never mind how to use it well. Then in addition, there's this huge movement in the IT world to move away from monoliths and microservices. And we're all trying to become high-performing teams. So we're trying to figure out how to develop software quickly and deliver business value to customers as quickly as possible so that we can get feedback and we can iterate, right? So rather than spending years in an ivory tower working on a huge monolith, we want to create little microservices and get them in front of users really quickly and get feedback and then iterate quickly and quickly. So we basically want continuous integration and continuous delivery with containers on Kubernetes, on any Kubernetes cluster, public or private cloud, which is a kind of an issue, right? This is suddenly, there's all this stuff we all have to do. So if you're a team right now who's trying to deliver software value to your customers, You have all these things you need to figure out. Right? You need to figure out how to set up your Kubernetes cluster, how to set up your environments like development, testing, staging, production, how to move your software into containers, how to deploy those containers on Kubernetes. Kubernetes uses this YAML stuff for generating deployment descriptors. And then there's this other thing called Helm charts, which is seen as the canonical way of packaging applications for Kubernetes. Helm is like a package manager for Kubernetes. Then people need to figure out how are you going to do continuous delivery and promote released applications between testing, staging, and production. And then there's this thing called GitOps that is a term that Weaveworks folks made up last year, which is a really good term. That increasingly, when we start to do high-performing teams and we're trying to do operational stuff, like how do we manage what's running in a staging environment or what's running in your production environment, a common practice is GitOps, which basically means store all of your environment-specific configuration in Git. So everything's versioned and audited and has history. So then if ever somebody makes a change in production, they make a change through Git, not directly with the production system. So that if all of a sudden production goes pear-shaped, you can just look, who did the last commit in production? Maybe we should roll that one back because that might fix the problem. So GitOps is the new hotness in how to do operations. So we've got the Kubernetes, the containers, the moving to Helm, moving to continuous delivery, adopting GitOps. Then we need to automate everything because we need to spin up lots of different microservices whenever we feel like, so we can do experiments. And then we need to get the feedback back to the development team from all of this kind of stuff. Then once we've figured out all of that stuff, we then need to actually do the business value that we're meant to be doing in the first place. So basically today, we have all this stuff we have to worry about and figure out before we can really become a high-performing team. And that's really where Jenkins X comes in. Jenkins X is really trying to help you continuously deliver business value through software without really having to worry how to set up CI and CD, how to deploy in Kubernetes, without having to totally understand what a Helm chart is, what a Docker image is, how you should package applications for Kubernetes, and how GitOps should be even set up. It's trying to optimize all of that kind of stuff to help you get going quickly, right? So what does Jenkins X do for you? So the first thing Jenkins X does is it configures a whole bunch of tools. One of the lovely things about Kubernetes is there's a massive, vibrant open source ecosystem. One of the downsides of Kubernetes is what tools should you pick and how should you plug them all together to get a fast, efficient CI/CD experience.
Right.
So
this is the typical thing with open source where you have a lot of options, right? Exactly.
And Jenkins is notoriously challenging in that world as well. You're faced with Jenkins often traditionally is there's 2,000 plugins or 1,000 plugins. Which ones are the ones that you think you need for your use case, right?
So Kubernetes doesn't solve that, and Jenkins X doesn't solve that particularly in terms of the set of choices that you have, right?
Well, what Jenkins X does a few things. What Jenkins X does is it's an opinionated choice of open source solutions, plus Jenkins X integrates them all together for you. So rather than you having to Google on the internet, how should I do CI and CD, and you find a gazillion different tools that do a piece of the puzzle, what Jenkins X is trying to do is glue all of the best of breed tools together into one simple to install package. Then it also takes care of upgrading these tools because each one of these tools has its own release cycle, right? So there's tools like Helm and Scaffold and Nexus and Monocular. There's a whole bunch more. Each of these tends to have a fairly rapid release schedule and changes quite frequently. So another thing Jenkins X does is it takes care of upgrading so that as new versions of Scaffold comes out or Helm or Nexus or Monocular or Chart Museum and various other bits and pieces, plus Jenkins X itself and Jenkins itself. So all of these tools are changing all the time. So Jenkins X takes care of installing and configuring and upgrading all those things, right? So you don't have to sit there.
It does do that, I was thinking, my bad.
Yes, so it does do that, which is a good thing. So that's a good thing.
Mm-hmm.
And then the other thing it does is not just integrate all those tools together, it then automates how you set up your CI and CD pipelines for your actual applications that you're building. So as soon as you have an application, you might be creating it from scratch, you might be importing it from some source you've got in Git somewhere, you might be using a Quickstart or whatever. as you bring an application to the table, Jenkins X will automate setting up the pipeline to do CI and CD. It'll automate creating the Docker images, and it will automate creating the Helm charts. So it will basically automate the CI and CD stuff, using best practices for how you should be doing this on Kubernetes, right? Which is using GitOps for promotion. It's using a clean master, so master's always releasable. It uses semantic versions in every release, which we'll see in a moment when we do the demo. So it's using GitOps to do all the promotion. So we release everything once with a unique version number, and then we move that package, that Helm chart and those Docker images, we move them from testing to staging to production through this GitOps process, which we'll see a demo of how that works in a few minutes. And I can show you a bit more behind the curtain what actually happens when all that kind of stuff happens. So this is the big thing that Jenkins X is trying to do for you. It's trying to give you the best suite of tools all configured for you, and then it tries to automate your CI and CD pipelines to do the right thing in Kubernetes with Docker, with Helm, with pipelines, with GitOps.
So just to be clear though, this works, Jenkins X works when basically that your whole test to staging to production are all in Kubernetes. If you're this doesn't handle the case where your production or staging or these things are not on Kubernetes.
Yes. So Jenkins X focuses purely on the Kubernetes use case.
Now that's a pretty broad use case, but
yes, I mean we're actually using Jenkins X to build Jenkins X, and lots of pieces of Jenkins X are like libraries and npm packages and Docker images and stuff,
right,
which by themselves they don't go to staging and production. So you can use Jenkins X just as a way of releasing things, but the promotion side of things, the continuous delivery, the D piece, the continuous delivery, that kind of assumes you're delivering the software somewhere. And so for continuous delivery, Jenkins X assumes that's a Kubernetes cluster of some kind. We are working on some serverless stuff, so that if you're doing serverless, but you're not using Kubernetes directly, so you're more using something like Lambda on Amazon or something like OpenFAS or Kubeless or something like that on Kubernetes, possibly. We hope to have continuous delivery for those, but we're not really addressing things like folks who want to deploy virtual machines onto some infrastructure as a service kind of provider or some VMware thingy or OpenStack or whatever. Right. We're not really focusing on that right now. Longer term, we could look at extending Jenkins X to handle things like Terraform or Ansible or something like that for the deployment side. But we've not really looked at that yet because we feel that Kubernetes is going to be a pretty big deal. It's the preferred way of deploying containers on all the 3 major clouds already. Red Hat promotes Kubernetes as the way of deploying containers on Red Hat's operating system. Cloud Foundry supports Kubernetes as a preferred way of deploying Kubernetes. Pretty much everybody, even Docker supports it, right? Like everyone supports Kubernetes now as the way of running containers. So we think for most enterprises, Kubernetes is going to be the key way people are going to end up moving to deploying their software. However, obviously Jenkins can do anything you want it to do. So there's always Jenkins if you're not using Kubernetes. But
okay, cool.
Jenkins X is very much Kubernetes focused for now. Okay. So the next thing is, this all sounds kind of cool. So how do we get started? How do we set up a Kubernetes thingy, and how do we put Jenkins X on it? So the first thing you need to do is get a binary tool called JX for Jenkins X. If you click that URL, or if you go to the Jenkins X website and do a couple of clicks, you can download the binary yourself. It's a fairly small binary, and you just need to put it in your path. It's a statically linked binary, so you can install it on pretty much any operating system, and it just kind of works. If you're using a Mac, you can use brew to install it if you prefer. If you're on Linux, you can copy and paste those commands if you prefer, or you can just download the binary from the GitHub website. So once you've got this binary, and you put the binary on your path, you then need to run one command to either install and create a cluster, a Kubernetes cluster with Jenkins X on it, or if you already happen to have a Kubernetes cluster, you can run the second command, JX install. So the first command is what we prefer you to use. It's JX, then create, then cluster. Then the next argument on the command line is the kind of cluster you want to make. So AWS is for Amazon, which uses kops under the covers to spin up a Kubernetes cluster. GKE is for Google, which is a really, really nice way of running Kubernetes right now. The GKE seems to be a little bit ahead of all of the public clouds today, but Amazon and Azure are catching them pretty quickly. And then AKS is if you're using Microsoft Azure. So all three of those commands look and feel pretty much the same and are very similar arguments and everything. All that happens in those three commands is it uses your credentials to log into Amazon, Google, or Azure, spins up a Kubernetes cluster, then it installs Jenkins X on top of it.
So if I don't have an account with any of those, do you guys support local running, like with Minikube or something like that?
Yes, you can use Minikube. We actually recommend you don't, though, to be honest, just because so many people have trouble running Minikube, because Minikube depends on virtualization on your machine. It depends on bits of Docker for Mac or Windows running. People have so many issues running Minikube on their laptops. It's kind of quite surprising how much issues people have with it. So I honestly recommend people try the public cloud. They all have free tiers. Yes, you need to register. Yes, you may have to type in a credit card, but it literally can spin up Jenkins X on the public cloud and tear it down after a day. And normally you're within the free tier. It doesn't cost you a penny. And using the public cloud, you'll get used to experiencing what it's really going to be like, right? I don't know about you. At home, I've got pretty lousy Wi-Fi. Doing Docker builds and downloading Docker images and stuff on my laptop takes like forever. Whereas I can spin up a cluster on Google in like 2 minutes and I'm ready to run, right? On my laptop, it takes like an hour, and then every Docker build takes like 20 minutes because it's downloading the internet onto my laptop. So we do really recommend, if you can, please try the public cloud. The other thing about the public cloud is you can use webhooks on the public cloud. So whenever you're doing like you're getting push events on GitHub repositories or whatever, Minikube, webhooks don't really work on Minikube. So you're
because you're sitting locally behind your own firewall, and then you can't.
Exactly. Yeah, exactly. So we do recommend, if you possibly can, try the public cloud. Plus, we kind of want you to use this for real. So we kind of rather try it out in the public cloud if you like it, keep using it, and your team now have a CI and CD platform you can use for real. No one's going to use your laptop for real for CI and CD on the team, right? So
sure.
We prefer you to go public cloud, but hey, Minikube's an option if you don't mind waiting a very long time to try that.
Just because of downloads and stuff like that. Yeah.
Just because of downloads and things like that, and the lack of webhooks. Yes, so you can manually keep triggering builds yourself because there's no webhooks on Minikube. But yes, so create a cluster, preferably on the public cloud. But if not, it's fine. Use JX install or use Minikube instead of in create cluster. You can do JX create cluster Minikube. That does kind of work if Minikube works on your laptop. Which,
assuming this thing that might be difficult. This other thing should work.
Exactly.
Okay. All right.
And there's all kinds of, lots of people have tried Jenkins X with Minikube and had loads of failures with it. And it's always to do with Minikube and not to do with
the local configuration, basically.
Yes, like which version of Vagrant and HyperKit and Docker for Mac have you got on your laptop and all those kind of things.
Okay.
So all kinds of stuff can go wrong basically with Minikube. So please, if you are trying Minikube but it doesn't work, don't assume that's Jenkins X doing bad things. It's just Minikube is tricky to run, right? Plus another thing, some people don't have much memory in their laptops. What we kind of want to be doing is like we want to run quite a lot of stuff in Kubernetes, right? We want to run Jenkins and builds and Nexus and a bunch, and then your actual apps. A lot of people, don't have 8 gigabytes of memory free or whatever. So yes. Right. So anyway, so pick one of these that you like. Sure. Minikube is okay, but we'd rather use a public cloud.
Okay.
I have a real quick video of what it looks like to install on Google, but they all pretty much look about the same. I'll just hit play. This is slightly sped up. So you basically type JX create cluster GKE. I didn't want to do a live demo of this just because it's kind of boring because it doesn't really do very much. And it takes like 2 to 3 minutes. And you're mostly sat there waiting for the cloud to spin these things up. But basically, you type in JX create cluster GKE, hit return. It asks you for which nodes you wish to use and which regions. It sets up something called an ingress, which is like a load balancer thingy. Installs Jenkins X and all the various pieces. Then finally, you can just see the last piece. It creates 2 Git repositories, which we'll come on to later when we do the demo. 2 Git repositories, which are used for GitOps, which are your staging and your production environment's Git repository, which those bits will become clear when I start actually kind of demoing it. So what does that give me, right? If I create a cluster with Jenkins X, what do you get? What does each team get? So each team basically gets their own development tools environment. So each team gets their own Jenkins master, which means you're not going to be sharing one Jenkins master across gazillion teams. And whenever you go to the console, if you go to the console, you're not going to see every single build for every single person in your entire company. You're just going to see your team's builds. And each team gets an elastic pool of build pods. In other words, whenever your team asks to do a build, for whatever reason, so you commit to master or you create a pull request or whatever, a build will be triggered automatically using Kubernetes as a scheduler. So rather than having like a fixed number of agents or whatever in Jenkins, we use the Kubernetes plugin for Jenkins under the covers so that each team has an elastic node pool of agents, which is limited only on your the capacity of your Kubernetes cluster, basically. So long as you have capacity in Kubernetes, you can run a build. Each team also gets their own monocular, which is like an app store thingy. Then each team also gets their own staging environment and production environment. And what that basically means is each team can release apps to their staging environment without asking for approval, without raising tickets and getting different people to let them in. So it means from a classic microservices world, you can go quick, right? Each team is empowered to build and deploy their own software in their own environments without impacting any other team. Under the covers, the staging and the production environment are using a feature of Kubernetes called namespaces. And what namespaces mean is the staging namespace is completely isolated from the production namespace. So that if you deploy a microservice or something to staging, it can't see anything in production and it can't interfere with anything in production. These environments are completely isolated so that you can't accidentally use the production database for your test or something. When you drop the database in your test harness, you don't accidentally do that on the production database and vice versa. So it gives you that level of isolation between environments, even within the same team. And then each team's environments are obviously isolated from each other too. So if you have like 10 teams all sharing the same cluster, you're not going to interfere with each other directly. Okay, right. What I'll probably do now is do a live demo on, in this case, on Google Cloud. I'll do a live demo of creating an app on Jenkins X, and then we can walk through and see, so you can see how it all works and how we can automate CI and CD. So I'm in a little command line shell here. We have a little command, JX is the command line tool, which if I just type JX, I get a big list of, there's gazillions of commands to type.
So I'm gonna interrupt you for just a second and
go for it.
Make that larger.
Okay, sure.
Just a couple of pops up. There we go. And maybe scoot your screen. Well, okay.
Yeah, let me shrink it a little bit.
Yeah, scoot your terminal window down a little bit now.
Yeah.
Shrink that a little.
Let me make it a little bit smaller.
So
it's gone crazy big.
Yeah.
Let me just shrink it a little bit.
One more until you can grab the edge.
Yeah.
There we go.
Is that okay?
That'll work. Yeah.
That'll work. Cool. Just let me make it a bit wider so it doesn't wrap horribly. So if I type JX get env, see if this wraps horribly. Yeah, it wraps a little bit horribly. Let me just make it slightly bigger so it doesn't wrap too badly. There we go. That doesn't look too bad. Okay, cool. So here's all my environments that I've got right now. So the development environment is the first line. That's where the software tools run, like Jenkins and those other things. I have something called an edit environment, which is where I'll show you that right at the end. But that's where I can develop. I can work on things inside my IDE that only I can see. And then we have the team staging environment and team production environment. I'll talk a little bit about what those are and how they work later. But first, what we're going to do is create a new application. Now, we support a whole raft of different languages and libraries and frameworks and stuff. I'm actually going to start with a Spring Boot application, just because Spring Boot is one of like the most popular framework of the Java ecosystem. If you're going to make a microservice these days, people typically tend to reach for Spring Boot first. So we'll start with Spring Boot. So there's a command, JX create Spring. And what this does under the covers is it uses something called start.spring.io that the Spring folks create. So there's this Spring Start initializer, which is like a wizard that helps you spin up new Spring Boot microservices. And I get to choose which programming language I wish to pick, and I'll go with Java. Which group ID do I wish to use? I'll just use the default. What's the name of my app? let's call it webinar grid. There we go. There's a handy name. Now it's asking us, this is a Spring Boot thing now, it's asking us which Spring Boot dependencies do we want to include in this application. So I'm going to hit space to pick the actuator, and then I'm going to search for the web stuff, and I will add the web thing too. So we've added the actuator and the web dependencies. Oh, hang on 1 second. Excuse me a second, I was in the wrong namespace. All right, let me do that one more time. Forget you saw that. I was messing around on something before this webinar, and I forgot to switch back to the right namespace. Okay, try that again. And we'll call this, do this one more time. That one, group, artifact ID, we'll call this webinar James. Actuator, and we'll do web. Yep, there we go. Ooh, that's better. And then it's going to ask, do we want to initialize Git? Yes, we do. So these are the files that it's created, which is basically the same things that start.spring.io would create if you went through the start.spring.io website. And what it's going to do is it's copied these files into my local file system in this directory. And now it's going to add them into a Git repository, which is cool. So it's added the Git repository. Now it's run something called a build pack, and it's added in a bunch of extra files to enable things like building things with Docker. There's a Docker file. It's added things like a Jenkins file. I'll talk about these files in a moment. Now it's asking where should we store this Git repository in a Git server. And so it's asking us on GitHub, where do you want to store it? And I'll store it in my personal account. And it's going to use that repository name. And so now what it's going to do is it's doing a git push. It's going to create a new repository on GitHub, and it's now doing a git push onto GitHub. Now, if I type it, copy and paste this command here, it's going to copy and paste that straight in. What that command's going to do is it's going to visualize what pipelines are happening in my project to the terminal. So as things happen on that project, it will just echo to the screen. So as I go through this demo, we'll see things happen on that terminal. Okay, so what's happened on the covers? You see a pipeline is triggered. So what we did there, let me click on this URL so to make it cheating really. So this is the Git repository I've just created. There we go. So it's a normal Git repository with the normal Java stuff. There's a POM XML there with normal POM XML stuff. So that's a normal Spring Boot Quickstart, which is based on the canonical source code. If I just look in the source, this is a normal source code of a typical Spring Boot app, right? It's not terribly exciting. It's just a vanilla, empty Spring Boot application. But notice a few other things. Docker, how we turn this source code into a Docker image. So that's the Docker file, which was generated for us from the build pack. We also added a Jenkins file, which is a declarative file to describe all the steps we need to make to run the CI and the CD pipeline. Right? We don't need to worry too much about the contents of that. Then under the covers, we also created this charts folder, which is the Helm charts for packaging the application up and deploying it onto Kubernetes. So we've added a bunch of these files into Git for you. So we have a whole range of build packs which automate building Docker images and CI and CD pipelines for those kind of programming languages, whether it's Python or Ruby or Go or Node.js or Gradle or Maven or whatever it is. Right? So we have all these different build packs that automate that stuff for you. So you don't need to worry about it anymore.
So when you say we here, you mean this is what Jenkins X is doing for us? It's generating the charts,
it's generating all this stuff,
generates the Jenkins file. Okay.
Exactly. Now, what it does is it looks in your project and goes, do you have a Docker file? Oh, you do. We'll use it then. So it uses what you have, but it will basically override. It will add these things if they're missing.
And right? Just for a second, could you zoom in on just Command plus
yes.
the GitHub page there?
There you go.
Yes. There we go. Perfect.
Is that better? Yeah. So we add all these files in for you. And then we automate. So what we kind of did there, I typed one command, which created this application. So in one command, JX create Spring, we created a new Git repository with source code inside it. What it also did under the covers was it added some webhooks. If I go into the settings and we look at webhooks, we'll see it's registered a webhook that says whenever we do a push on any of the branches, trigger Jenkins and to do the CI and the CD. Also notice that it looks like we've started to do promotion. So that means we've built a release. So if I click on the releases tab, Notice we've got 001. So we've tagged the source code as 001. So we can now look at the exact version of code that is being built as 001. And we've generated some release notes. The release notes aren't very interesting yet because we didn't do a whole lot in the source tree yet. So what we've done under the covers is the release pipeline has generated a new semantic version, 001. The next time we do a push to master, it's going to generate 002 and 003. It's using the Git tags on the Git repository to keep track of what version has been released. So that if ever we wish to jump from 001 to say 100, we just create a Git tag called 100, and then the next release will be 1001. Another way you can force the version numbering scheme is you can edit your POM XML. And by default, the version says 001 snapshot. If you edit that to be 100 snapshot, then the next release will start with a 1. Right? So you can use the POM XML or the package JSON to define what's your major minor version numbering. Otherwise, it will just assume everything's a kind of a patch release. Right? So we've built the release. We've versioned everything 001. We've built a Docker image. We've built a Helm chart and released those. So 001 is now a mutable version. As you can see here, 001 is an immutable version that you can now use in any Kubernetes cluster anywhere. But now we're doing this GitOps thing where you see there's a pull request being generated. Let me click on that one. If I click on the pull request, this is a pull request to promote 001 into the staging environment. Notice we're in the staging environment. Strachan test 3 is the name of my cluster right now. So that's the name of the Git environment. What this is doing is it's generating a pull request on the environment. And don't worry too much about the details. This is the change required to add this new application into a Helm chart. But what's interesting is we're not copying the Docker image and we're not copying a blob of YAML or anything like that. We're copying a reference, the version number, to a Helm chart that we've released into this chart museum repository. So this is a little bit like updating a POM XML to add a dependency, where you're adding a dependency by name and version. So we're adding a new dependency, webinar James, and we're adding 001 as a pull request. I think that pull request should hopefully merge fairly soon. What's happening is, notice that there's a CI job is now running on the staging environment to validate, is this pull request on the staging environment valid? So it's running whatever our CI tests are for the staging environment to test things like, has this Docker image been pushed to the Docker registry? Is this Helm chart available in the Helm chart repository? You may wish to add other validations to your CI pipeline, like has all the Docker images passed any CVE vulnerability checks or whatever else you wish to check for. You might also need to add, say, human approval, like, do we need a couple of +1s on this to say you can promote this version of this app into the staging environment? So hopefully,
that manual stuff that you're talking about, that's something that you can add?
Yes. So I didn't explain this yet. I should explain it a bit better. So there's a couple of different ways in which approvals can happen. So by default, each team gets a staging environment and a production environment. And by default, we set up promotions automatically on staging and manually on production. So whenever we do a release, by default, automatically we promote that to the staging environment, but we leave promotion to the production environment as a manual step that you choose when you want to do that. In addition, because under the covers GitOps is using Git, we use pull requests to generate everything. And those pull requests, depending on the config of your Git repository, you can have automatic or manual or approvals on the merge operations. So you can set up, I need 2+1s before you can merge this pull request. And you can leave the merge side of the pull request to be a completely manual thing. So you can choose when you're happy to merge those things. And by default, that's also automatic as well.
Okay.
So hopefully.
Quick question. So if you click on, details there in on the GitHub page, where does that take us?
So this takes us to the pipeline UI for the staging environment. You can see that this is just about finished. This is finished. So it's gone green. Okay. So if I reload this page, hopefully this should merge soon. I'm not sure why it's not gone green on the GitHub yet. Any moment now, GitHub should realize this is mergeable, and it's because it's green. I can see it's green. There we go, it's green. So any moment now, this should update github.com's webpage and it should merge. I'm just going to click the merge button, to be honest, just to speed this along a little bit.
Sure, yeah.
It should merge soon, but I'm just going to hit merge.
Well, no demo can meet reality without something going just not quite how you expect. It's okay.
I don't understand why that's not gone green yet. That should be totally green. Maybe GitHub's having a funny day. Okay, I'm just going to hit merge. Okay, I've hit merge. So now this is merged. So now, because we've merged to master, now the pipeline is running the update pipeline.
So you've merged to master in the
staging Git repo.
Okay.
So now if I look at the staging repository and we look inside the requirements, which are basically all the apps which are deployed, we'll see we now say webinar James 001 is one of the apps. So now another pipeline is going to run, which is going to apply these changes. So it's basically going to say to Helm, please install all of these charts into the staging environment. So once this pipeline completes here, which if I noodle around in my Jenkins, I'll be able to show you this pipeline running. There we can see there's the master branch. So any minute now, this on the staging. So this is the master branch on the staging environment. So hopefully soonish, this pipeline should chug along, and then they should apply 001 into the staging environment. And again, usually this is a little snappier. So hopefully that will kick off fairly soon.
So the limitation there is also that it's this is your Kubernetes sort of your number of nodes available that you can use. So it might be that. Yes,
and it does. On my cluster, I have auto scaling enabled. So if I don't use my cluster for a while, it scales down the number of nodes.
Right.
And so it sometimes takes a little while for Jenkins X to warm up as Kubernetes grows your cluster a little bit.
Can you again expand this a little bit? Just that, I mean, it's not a lot to see, but just spin it up so we people.
Oh, and it's gone green. That's awesome. So that's
okay.
That's gone green.
Thanks.
So hopefully this UI should update fairly soon because it's gone green. And if I go back to my other terminal, there we go. So it's promoted. We can see it's promoted.
Mm-hmm.
So 001 is promoted, and I wasn't scrolling my screen. That's why I hadn't updated. And there's the URL. If I click on that URL, any minute now, that's just starting up in Kubernetes. So this is the URL of the app that's running in the staging environment. I'll give it a few moments to start up. If I go to my other terminal, which I've hidden slightly under that window, let me move that down here. If I type JX get app, this will list me all of my apps in all of my environments. So I might have 5 different apps, some are in staging, some in production, and they're all different versions. This little command, JX get app, lets us see I've got 001 in the staging environment. There's no pods running just yet. There should be soonish. There we go. The pods are up. So if I click on this URL, it should work. Yeah, there it is. Now this doesn't look too impressive. This page. This is actually a working page. It might not look it. This is what a Spring Boot app generates by default because there's no code in it. So it doesn't know how to render anything, which is why it returns a 404. What I'll do now is I'll show you how a pull request works. And we'll do a pull request on this application, and we'll see how pull requests work with Jenkins X. And we'll hopefully make this page look something a little bit nicer, right?
So this may not look like a lot, but we've gotten to a running app, admittedly with an error page. We've gotten to a running app from basically just typing a couple commands, right?
Yeah, I mean, really, we typed one command, JX create string, and then all this has happened, right?
Right. So it's gone through.
It's
created repositories, created the staging and production GitHub repositories for us, and run a bunch of pipelines back and forth to make to settle this up. And now you're going to actually do a pull request into master in your regular repository, and then see that go to staging and then production, right?
Exactly. So, I mean, the other thing to bear in mind is what's quite common in teams is they'll often sit there on the laptop hacking away for a while until they're ready to show it to someone else. And then we'll go, oh, does this even work in Kubernetes? I don't know, I haven't even tried yet. Right. What we're trying to do is make people go the other way. Like, before you even start coding, we want to show you that your app works on Kubernetes. And then every change you make from then on should be making a pull request so that you can tell my new change still works in Kubernetes, right? So we want to get people going to staging immediately. And then every change you make from then on is ready to go to production because you're testing it on staging, right?
Right.
And getting people into that habit of delivering value properly on the cluster that you're going to run production on, rather than spending too much time on your laptop and not ever really testing it on the real cluster.
Sure.
So what I'm just doing, I've just created a little branch. I've used the command line git branch, git checkout. I've added a file. If I do git add source name resources and git status there, I've added a new file. And I'm going to do a git commit. I'll do everything on the command line because people sometimes get a bit confused with IDEs. Let's do a fix. Add better homepage. There we go. And git push. And so I've done a git push on a branch. So if I go back to this Git repository, and then we'll see that GitHub is saying, would I like to make a pull request? So I'll say, oh yeah, let's make a pull request. And let's submit a pull request. So I've just used Git here. I haven't done anything magical or weird. I've just done a normal Git thing. I've used the normal GitHub webpage to create a pull request. Pretty much every.
Can you show us the diff in that the files changes there?
Yes. So I've literally just added a new HTML file. That's all I've done.
Okay.
So I've added a new file into this static
one index. Yeah, right. Okay.
Yeah. So I've just added a file. Not the best diff you've ever seen. I should have maybe modified the file, but
no, that's fine. Of course, you're starting from empty space. So
exactly. So notice that a pipeline is triggered because we're in a pull request. Now, if you remember 20 minutes ago, we did the JX create Spring and that created a new project, which is a Spring Boot app, and it set up the pipeline. The pipeline handles pull requests and releases. So whenever you submit a pull request on this project, it will run a pull request pipeline that validates, is your code change valid? Do all of your test pass and whatever kind of code quality validations you wish to use. One other thing we do though with Jenkins X is we do something called preview environments. Oh, by the way, you'll notice on here, we'll see the pull request pipeline is triggering on here, right? So we can see pull request pipelines as well as master branch pipelines. So what's actually happening under the covers is we're running all the usual stuff. We're running the unit tests, checking all those pass. Then what happens is we create a preview Docker image of the code change before it's merged to master, right? So what we're going to do is we're going to create a preview Docker image. And then what we're going to do is spin up a preview environment to run that preview image. Then we're going to spin all of that up in Kubernetes, and then we're going to comment on the pull request with a link to where the app's running in the preview environment. Now, the reason we're doing this is for various reasons. Imagine you're building a web application. It's quite common for teams to do things like code review. As pull requests come in, you might want to get your peers to review your changes. If you're changing a web application, looking at the diff can be kind of confusing. Seeing a diff in a CSS file doesn't really give you an idea for how well a new feature looks in an IDE, in a web browser. So the idea behind preview environments is it does two things. It lets you test the application that's run before you agree to merge it. So if you're trying a new buy it button, you can let your team members review what it looks like before you agree to merge it. So it gives you a place you can have a better discussion on the pull request about what you think of a feature by seeing it run. Another thing you can do, though, the preview environment acts as a check that goes, does this change actually still work in Kubernetes? It's surprisingly easy to make a code change, such as adding a new mandatory environment variable or something like that, that if that environment variable isn't also set inside the Helm chart, your app now fails on Kubernetes. So it adds an extra level of testing that goes, does your app still work on Kubernetes before you merge it, right? And if I look at the pull request now, see how it's gone green because all the checks passed, but also notice this comment here. It says a pull request is built and is available in a preview environment here, and it gives you a link to a URL, which is also the link that's in the screen here. It's the same URL, but I'll click it on the pull request because it's kind of cooler. So if I click that URL, we'll see, when the pod starts up, it's not quite started yet. In a few moments, when this pod is up and running, because it adds the link before it's checked it's up. Oh, there we go, it's up. So notice that in the URL, we have the organization name, the repository name, pull request 1, preview is a namespace, or the place in which this runs. So each pull request gets its own environment where we can access this application. And this is basically the HTML page I just added. So this is the new home page. So we can verify, yes, this does look good, or at least it looks lots better than what we had before. So we can approve this pull request after testing it out, and we can say yes. Before I do that as well, we can type JX get app, and we can see these are the applications, and we can do JX get preview, and we can see these are all the pull requests. So here's the pull request I've just done, and that's where it's running. So we can easily, as a team, modify and view all the pull requests that are happening and validate them. And then when we're ready, we say merge to master. Now we're merging that code change into the master branch. And now, hopefully, another release pipeline will kick off. There we go. So version 2 is now, 002 is now. And so this version is now going to get released and be deployed into the staging environment. Okay. It's pretty cool.
And that'll be done via a pull request to the staging environment that'll then...
Exactly. Yeah. So just to recap what we've just seen, because it's maybe slightly confusing, I've been flipping between a few different consoles and looking at the browser a little bit. We typed one command to create a brand new microservice, and that immediately was released. It was built and released with a semantic version, and then promoted to the staging environment automatically through a pull request. Then we created a pull request ourselves on our app. That then generates a preview environment, so we can test out the application before we've merged it. And then when we merge it, we then release 002. So we've basically automated CI and CD without, as a user, you having to worry about what a Jenkins file is, or a Docker file, or a Helm chart, or even what Kubernetes is. A couple of other details about this before we maybe go into more questions is the other thing to remember, while Jenkins X is automating all of this for you, Jenkins X isn't actually hiding anything. So if you don't like the way the Docker file's working, you can just edit the Docker file. It's stored in Git with the rest of your application source code. Similarly, if you want to change the Jenkins pipeline to do different steps on the pipeline, on the pull request pipeline, or different steps as it's doing a release, you can edit these Jenkins files. Similarly, you can also edit the Helm charts. We're hoping that you don't really need to touch them, really. And we're hoping that our build packs will be sophisticated enough for you to do everything you need without even seeing them or touching them. But it's important to realize if you ever need to change them, they're right there in Git, and you can just go ahead and change them.
So you get the advantage of having them spin up and be a basic opinionated. Here's the best practice. You get that advantage, but you also get the control if you need it.
Exactly.
You can take back the wheel, as it were.
Yes, and one thing we're trying to do, we expect as large organizations start to adopt Jenkins X, they might want to start to tweak what build packs are used. There may be corporate standards of exactly which versions of, I don't know, the JVM needs to be used, or which Linux-based images, or whatever. So we can imagine people tweaking the build packs a little bit, so that they could fork our Git repository with a build pack saying, make a few modifications of, add some build packs, remove some build packs, modify them a little bit, so that at an organization level, people can modify those a little bit. We obviously want to try and get as much reuse as we can throughout everyone in the industry. So we want to avoid people just creating their own brand new build packs in isolation. If ever you created a build pack for, I don't know, some really ancient version of WebSphere or something, we'd love it if you contributed that back up to the community so we can all share it. But if you really want to do anything local within your company, crack on, and it's all good. So we hope to have a nice, diverse, rich community around the build packs themselves. But worst case, you can just modify them directly inside your application if you wish.
Got it.
Okay, so that's kind of CI and CD.
So do we have a staging pull request for this, for your change at this point?
Should be coming up. It should be coming up very, very soon. I should show you, by the way, one common question I get whenever I show this is people say, are you hiding the Jenkins console? The answer is, well, no. But what we're trying to do is make it easier for people to develop without necessarily having to keep going back to the Jenkins console all the time. But you can do a command JX open Jenkins, which opens the Jenkins console. So if ever you want to just look at the Jenkins console, you can just do that. And if I go into my pipeline, we'll see the master branch is chugging along, and it's now running the promote stage. So it's made the release, and it's now running a command line called JX promote, which is the promotion. I should have mentioned this before, actually. If ever you want to manually promote something, you can just type JX promote, mention the application name and the version you wish to promote and which environment you wish to promote it to, and you can just promote that application to the staging or the production environment on demand. A JX promote can also promote any application. So whether it's an application you build yourself, like a custom microservice, or it could be something that comes from the community, like Prometheus or Elasticsearch or Grafana. So we can do promotions using the JX command line ourselves outside of CI and CD if we wish. So that promotion is chugging along. So we should see a pull request. There we go. There's a pull request. So what's interesting about this pull request is because now this is version 002, the diff is going to be much smaller now. If you remember, the first pull request we saw had 3 lines changed because we'd never deployed the application before. Now, all we're doing is changing the version from 001 to 002, right? And then maybe in 2 weeks from now, if ever you decided you wish to roll back, you can either use the JX promote command line to roll back a version, or you could literally just do a pull request directly in the GitHub web console. You could literally just edit that version number back to 001 if you wished and submit your own pull request. So we're letting anyone can change the environment's Git repository through normal Git, through the GitHub web console or whatever Git provider you're using, or using the JX command line tool, which is nice. So
UI or command line, your choice.
Yes, exactly. Use whichever you like. We are working on a whole bunch of IDE plugins as well for VS Code, IntelliJ, and Eclipse, so that if you want to stay in your IDE of choice, hopefully you can do more of that from just in your IDE rather than having to, use custom tools. Or you might have just noticed that pull request merged. So I think fairly soon we should have that release chugging in the staging environment. I'll show you that in
So it merged to the master and the staging, which then means it spins up on the Kubernetes environment. Got it. Okay.
Yes. So if we go back to, I'm losing track of my windows. Here we go. So hopefully we'll see this is the staging environment's Git repository in Jenkins. And now the push to master pipeline is the master branch pipeline is now running. So hopefully that should start soon. There we go. It started. So hopefully in a few seconds that should be applied, and then we'll have 002 in staging.
Cool.
So there we go. That should happen really soon. So while this is just completing, I want to change tacks a little bit and just talk a little bit about development. In other words, how you use Jenkins X before you're ready to do a Git commit. Now, one of the challenges with using the cloud is traditionally developers like to develop on their laptops, right? Developers have installed a version of Java and Make and Maven and whatever, and they've got all this stuff running on their laptop and they run everything on their laptop quite a lot. One of the challenges though is that means you're always testing on a totally different environment to the one you're using for production and staging. So we want to try tempt developers into using the same operating system, the same container images, the same tools as your CI and CD pipelines are using and your staging and production environments are using. Right? So we want to try and encourage developers to use the thing that's as close to production as possible. Because one thing that happens a lot is you use an old version of Maven locally and a newer one in your CI and CD, or vice versa. Or using a different JVM, different operating system. You might think you have a horrendous threading bug, but that bug only happens on Windows, and you're running on Linux in production, so it doesn't matter, right? So
some slight environmental difference between where you're developing and where you're deploying, right?
Yes, this happens all the time. We've all heard the phrase, it works on my laptop. Right? And what we want to do is go, it works on the cloud first. That's the thing that we care about more than anything else. Running on your laptop should be a secondary thing that we should care less and less about. What we should be caring more and more about is, does this run in a Docker container in Kubernetes using, the Kubernetes networking stack and load balancer and certificates and secrets. And as we start to build richer and richer microservices with things like service mesh and secrets and load balancers and wiretaps and all of this stuff, we want to test more and more inside Kubernetes and less on your laptop. Also, by the way, that just worked. So hopefully 002 is now running. There we go. 002 is now running in the staging environment, as you can see. And if I do JX get that, we'll see 002 is, there we go. 002 is now in the staging environment. So that's all awesome. So yeah, so let's just talk about development for a second. What I'm going to do is I'm going to switch to another shell. Where did I put it? Here. And I'm going to open an IDE. I'm going to use VS Code for this demo. We're working on an Eclipse plugin and VS Code and IntelliJ. VS Code is the one that's slightly further ahead than all the others. This application is a Node.js application just to kind of show that we can work with Node, we can work with Go, we can work with Java, with Spring, with Maven, with Gradle, with Perl, PHP, Python, Ruby, Rust, all kinds of different stuff. So this is a very simple, this is even simpler than the previous example. This is a very, very simple Node.js application that basically serves a file. Right? It's not going to make you lots of money if you copy this microservice. This is not the world's most interesting microservice, but I want to show you how you can develop in the cloud while using your laptop. So a lot of us are all wedded to our desktop IDEs, right?
Can you, sorry, I got to drop in again. Can you expand that just a little, just so that if people want to see it?
Yes. Oh, now I need to know how to do that in VS Code. That's a good. Zoom in.
Yeah, it's okay. It's okay if you don't have it. It's.
Yeah.
There it is. Ding.
Let's even bigger. Is that big enough? Is that okay?
Fine. That's fine. Yeah.
Yeah. In this one, you don't have to notice too much about what's actually on the screen. But what I'm going to do is I'm opening up the command window in VS Code, and I'm going to do this DevPod command. So there's something in Jenkins X called a DevPod. So let me open the DevPod terminal, and then while it's running, I'll explain what's actually happening on the covers. So what this is doing is, right, let me step back a little bit so I can explain this. So CI and CD in Jenkins X uses something called a build pod. So it's a pod, which is a group of containers, which contains all the software tools for doing CI and CD. So in a Node.js application, that's going to have Node and NPM and Git and kubectl and a bunch of other kind of tools. If you're doing Maven stuff, it will have Maven installed and Java and Git and various other things. So we have these different Docker images with all the tools you need to do CI and CD, right? And these are all versioned and managed by Jenkins X. What a DevPod is a pod or a container that you can use in development, which has all the same tools inside. So inside here, I can type npm version, and there I can see npm is in this container, and I can type in git, and I can type in kubectl, getpod, and things like that. So I can run all of these different tools, which you need to work closely on Kubernetes if you wish, right? So we have basically a container here. But this looks like it's running on my desktop, but actually this terminal is running in a pod inside Kubernetes, right? So this dev pod is a terminal into a container in Kubernetes. So inside this terminal, I can run stuff in the cloud as if it's kind of on my laptop, right? So it feels like it's on my laptop, but it's not. It's all running in the cloud. So this means I don't have to install Node myself. I don't have to install Git or Make or any of the tools that CI and CD use, right? I can just share the same tools that CI and CD is using and maintaining. The other thing it's doing, if I do an LSAF, here's all the source code in this pod. Now this source code is synchronized from my desktop into the container in the Kubernetes cluster. So what that means is I can edit everything on my laptop in my desktop IDE, but I can compile and build and use it inside the cloud. And let me do a quick example to show you what I mean. We've got a little shell script called watch. And this watch command is going to build up the Docker image and then deploy that application into my personal edit environment, right? Then it's going to watch the source code for changes. Right, let me pop to another terminal. And if I type, oh, no, not another window. Let me go into another terminal. There we go. If I type JX get app, you should see we've now got in my local environment, I've got a new URL for where this is running in my personal namespace. So this is the application we're building right now, which I can browse it in my window. What I'm also going to do is I'm going to run a little command to just curl this URL every couple of seconds and output the message from this HTML. Okay, so I'm just curling this microservice in my personal namespace. So while that curls running, I'm going to go back to my editor and I'm going to edit the HTML page and I'm going to say hello world from awesome. I've typed the word awesome, and you notice, you see the build that's just rebuilt in this terminal down here? What happened there is I typed in my IDE, My IDE synchronized that source code change into the pod that's running in Kubernetes. That then kicked off a Docker build to rebuild that container image. That then redeployed the Helm chart. And then any moment now, this curl command should return the new text, hopefully, once the load balancer. There we go. Awesome. So what I did is I did a build in the public cloud and then did a rebuild when I changed the code. And it rebuilt in like, what, 5 seconds. Right?
So it took the service down, brought it back up in the new form.
Exactly, right. In the new form. So it means we can make any change to this source code, whether it's the front-end code, the back-end code, the Docker file, the Helm chart. We can make any change we like, and this will redeploy on the fly to my personal environment quickly. Now, I don't know about you.
Not even a staging environment, but a personal environment that you're
a personal environment. So you get
yours.
Rapid feedback, right? You get rapid feedback as you're trying things out and playing around with this. You get rapid feedback of your changes, right?
And that environment has not just your app, but also its own, in this case, an NPM, so that if you were basically publishing that change, if you NPM release that, it would go to the local server and be able to run from there, right?
Yes, and so the idea of these development environments is this is where you can just run stuff before you're ready to do Git commits and pull requests, right? So the idea is when you want to do a real preview environment with make a real public Docker image and whatnot, that's when you do a pull request. But at this stage, you're just doing a really quick rebuild and redeploy locally. And then it's up to you what else you want to use in your personal namespace. You can link to other services from externally. Let me do another one, really awesome. And let's see, a couple of seconds later, it rebuilt. There we go. Now, I don't know about you. When I build a Docker image on my laptop, it takes a very long time, right? Inside the public cloud, this is fast. This is like a couple of seconds, and it's already redone. And hopefully this shell, I wasn't scrolling all to the bottom. There we go. And it's really awesome already, right? So that was like, what, 4 seconds, 5 seconds?
Right.
Now, what we're doing right now is actually a brute force. Every time you edit the source code, we're actually rebuilding a Docker image from scratch and redeploying a new version of the pod with a new version of the image. We're hoping to optimize this much quicker so that you can get even faster turnaround time. So you type something, for example, with Node, you don't really need to rebuild a Docker image each time. You can literally just start Node in watch mode and just copy the files into that container, and you don't have to stop and start the application, right?
Got it.
So for different programming languages and frameworks, we can go much, much faster than this. But this is just a quick example of how you can use the same tools that CI and CD is using in development. So you don't have to worry about maintaining the same version of Node or Maven or Java or whatever on your laptop, but also you can do really fast incremental builds in the cloud, right? I never use Docker on my laptop anymore. It's just way too slow and error prone, right? If ever you do a Docker build, you're pulling huge amounts of images down to your laptop, and then you have to do a Docker push, which is really slow, and you're pushing gazillions of bytes back up to the cloud, which is really slow. If you do your Docker builds inside the cloud, it's usually really, really fast.
And then all you're doing is pushing the code back and forth. Just the code, not all the artifacts.
Exactly. Usually source code is much, much smaller than Docker images, right? Usually. Usually. One thing to be very careful of, by the way, is the synchronization stuff that works inside Jenkins X. We exclude node modules and the local target folder. If ever you accidentally decide to synchronize node modules, if you're a node person, node modules can be massive, right? When you do like npm install locally. So you just got to be ever so slightly careful that you really are synchronizing the source code you want to sync, which is all defined by this magic file stignore, which takes care of all that for you. But yes, so there we go. So that's a quick taste of doing development. So what we're really trying to do with Jenkins X is we're trying to optimize every aspect of software development. Our initial focus is very much about how do we automate CI and CD on Kubernetes with multiple environments, with promotion through GitOps, and how to automate all that stuff for you. But we also very much want to help people in the development phase, right? So make it easy for people to test things, build things, incrementally change their code. And over time, we want to increase this scope and make a much more powerful and rich environment so that people can basically be productive with the cloud, developing software. So that's pretty much all I was going to do from a demo perspective. I was just going to leave some slides up with some links.
I was going to ask how about some links.
Yeah, so if you want to try out Jenkins X at all in any way,
Oh, you faded out there. Looks like James lost his sound. Yep. All right. Well, actually, this is okay. Main point here is that's Jenkins X. Here are some links for you: the JenkinsX.io website to try it out, or JenkinsX.io community to give feedback. There's a Slack channel, and you can also which is let's see here. And you can also go to the CloudBees website, pages.cloudbees.com, K8X, to get other information. What else? We also have, you can look for the Jenkins online meetups on meetup.com. Oh, James just told me his laptop died. Glad we still have this up then. In any case, thanks everyone for joining us. I will see you on the Slack channel or on the Jenkins IRC.